Okay, this is SAT Test 4 Section 6, and this might be a rather quick video because I have a time crunch here. So let's just start right away with question number 1. What number, when used in place of the diamond, makes the statement true? Okay, you can just pick numbers for this. Best thing to do, though, is to make it an improper fraction, so you get 15 halves. So what number do you put in there to make 15 on the top? It's going to be 12. Okay, in the figure above, line L is parallel to M. Then the sum of the measures of angles 2 and 4 must equal the sum of which other pair of angles? Well, we know that this is going to be the same as this, and we know that this is going to be the same as this because corresponding angles are congruent. So if 2 and 4 add up to something, 6 and 8 must also add up to the same something. I'm trying to go too fast here. Okay, this one, a lot of reading for what you, not much information. The table above describing Preston City workforce is partially filled in. Based on the information in the table, how many women in Preston City workforce are unemployed? Are unemployed. Oh, okay, I actually read this question wrong. So we can figure out how many women there are by subtracting these two numbers from the total. So the number of women are 2,100. And then to figure out how many are unemployed, we subtract these two numbers and we get 500. So the answer to this one is 500. Pretty easy one. Throw in there. All right, a group of students washed cars to raise money. The net amount, A, in dollars raised by washing K cars is given by that function. If the group washed 15 cars, what was the net amount? Well, this is the amount. K stands for number of cars. So we are given that there's 15 cars, so we're going to put 15 in for K to figure out the net amount. So 4 times 15 minus 30 is going to be 60 minus 30, or $30. And that would be E. All right, back up. XR equals V, and V equals KR. RV does not equal 0. Which of the following is equal to K? Well, if this is equal to V and this is equal to V, we can set them equal to each other. So XR is equal to KR. The R's cross out, and guess what? K is equal to X. That one was just a little too simple if you could see the little trick in there. I guess you could pick numbers. There's probably a variety of ways to do that. But since they're both set equal to V, you can set their parts equal to each other using the transitive property. Okay, a little ratio problem. So the eggs in a certain basket are either white or brown. If the ratio of white eggs to the number of brown eggs is 2 to 3, each of the following could be the number of eggs in the basket. So this is talking about the total. So we want to get a total column. So we have white eggs, the ratio is 2, to brown eggs is 3. The total is 5. So they're saying which one could be the total number of eggs in the basket? Well, if we multiply these all, just say we multiply these all by 2, we're going to get 4, 6, 10. If we multiply these by 3, we're going to get, if we multiply the 2 by 3, we're going to get 6, 9, 15. And you can see your total column is always going to be a multiple of 5. You can't have anything but a multiple of 5 in your basket. So the only one that isn't a multiple of 5 is 12. These come in handy. A lot of the ratio problems, you're dealing with your total. Make sure it's a multiple of your total for the other totals. Okay, hopefully that was helpful in that one. All right, let's move on. 7 and 8. Just waiting for it to load. Here we go. All right, this is a little tricky. 8 square root of 18 equals R square root of T. There's not much you can do. You can't say that, you can't say R is equal to 18 and T is equal to 18 because it says here R has to be greater than T. So that won't work. But what you can do is you can simplify this half. We know that 18, we can simplify the radical into 9, square root of 9 times root 2. And so that's going to be 18 times 3 root 2 equals r root t. 18 times 3 is going to be 54 root 2 r t. Now we can see what r and t are. R is going to equal 54, which is greater than t, and t is going to equal 2. This is r, this is t, and they want to know what r times t is. I can't really read that. R times t. So you multiply these two together and you get 108. All right, another tricky one. I remember doing, you can take a lot of time with problems like these. I remember having one like this and just taking too much time. But here's the deal. In the figure above, what is the value of c? Here's a little c hanging out right there. In terms of a and b. It means when it says in terms of, a and b are going to be in your answer. You can see a and b are in all these answers. So you can either, there's two ways you can do this. You can either pick values of a and b that add up to 180. You'd have to just a c too, value of c that would add up to 180. I guess that would work somewhat, but I think the better way to do it is to recognize that you have all the quadrant angles or the vertex angles of a quadrilateral. You always have to be thinking outside the box for SAT problems, especially when you're getting to the difficult ones. So if you look right here, we have a quadrilateral that has all the angles to it. And we know that the degrees of a quadrilateral add up to 360 degrees. So we can take all of the angles in the vertex angles here. So we have A. If we move, that's this one. If we move over here, this is going to be B plus, oops, I can't read it anymore, I wrote on it. That's going to be B plus B. And then we're going to take this one here, which is A plus C. And then our final corner right here is going to be B. All of these angles have to add up to 360 degrees because it's a quadrilateral. You can play around with those triangles, but you're not going to get very far. That's why you have to think outside of the box with these guys. The other way you could do is you could say, I'll finish this in a minute, you could say let A equal 70, B equals 60, and then C would have to equal, they still use the quadrilateral thing, so it's not that helpful to pick numbers. I think this is easier. So you have your quadrilateral, you have all your angles in the quadrilateral, so we're going to add them up. So we get 2A plus 3B plus C equals 360, and it says they want it in terms of A and B, which means you're going to solve for C so that's in terms of the other one, other letters. So we're going to get C equals 360 minus 2A minus 3B. So E is your answer. And that was the most difficult one on the first part of this section. Now we have the grid-in section. So here we go. Start out easy again. So once you get over those difficult ones, take a breath and start these easy ones. Okay, t to the third equals 351. You don't have to figure out t because this one says 4t to the third. We know t to the third equals 351, so it's going to be 4 times 351, and that's going to equal, for your grid-in, 1,404. Coordinate on a number line that's in between 53 and, let's have our number line here, between 53 and 62. All you do, you want the one right in the middle here. You take 53 plus 62, and you're just kind of finding the average. So you're dividing it by 2, and when you do that, you get 57.5. So you add them up, divide by 2, it gives you the point that's right in the middle. All right, a certain triangle has two angles that have the same measure. If the lengths of the two sides of the triangle are 50 and 30, what is the least possible value of the perimeter of the triangle? So a certain triangle has two angles that have the same measure. So we're talking about an isosceles triangle here. So we can either have this one where these are 50, 50, 30, because they're going to have two base angles the same. Or there's another one you could have. Whoops, I didn't draw that very much to scale. We're going to have one where we have 30, 30, 50. So which perimeter is going to be smaller? That's the tricky part for this guy. This perimeter is going to be smaller, so you add 60 and 50 and you get 110. Okay, next tricky one. X squared minus y squared. I'm not going to have enough room for this one. And we have x plus y equals 11, just to write that out a little darker. So this one we could factor. And watch what happens. We're going to need x plus y, x minus y. And it tells you right here that x plus y is 11. So we're going to have 11 for that one. So what do we know that this one has to be? Well, it has to be 7 equals 77. Now, we need to know what x and y are. So we know we can make two mini baby equations. We can say that x plus y we know equals 11. And now we know that x minus y equals 7. So if we solve these, we get 2x equals 18. X would equal 9. All right, moving right along. All right, we have this pizza cut into wedge-shaped pieces, of which is shown. The tip of each piece is at the same. I have to read from my book. I can't read that. The tip of each piece at the center is, and the angle is that the tip is always greater than 20 but less than 30. What is one possible value for the number of pieces which the pizza can be cut? Okay, so you're going to take 360 and you're going to divide it by some number between 21 and 29. And you're going to come up with your values. So, I mean, you could start just taking 21 into it, and I do believe you're going to get 17 point something. So that would be one of them. You could, ones that come out even are 360. You have a calculator to do this. If you divide by 24, it goes in evenly, you're going to get 15. So for this one, it's just a division problem. It could be anywhere from 13, 14, 15, 16, and 17. Just remember, when you're figuring out these angles, you just take and divide the degree into 360 degrees. So any of those would be correct. All right, the first term in a sequence is A, and each term after it is 3 times the preceding term. We need 5 terms. 1, 2, 3, 4, 5, and it has to equal 605. So we just put them in. The first term's A, the next one's 3A, the next one's 3 times the preceding, 9A, 3 times that is 27A, 3 times that is 81A. You add those all up, which I don't have. I guess I did it in my calculator. You add these all up, which I don't have a calculator right now, and you're going to get something A equals 605. Divide 605 by that number, and we're going to end up with A equals 5. Sorry, I don't have that one for you here. So add up all these, so you get something A equals 605, and then you divide both sides by the something, and you get 5. All right, next one's a little trickier. We have to squeeze everything in this little tiny spot, and we have to hurry too, because I'm going to time thing. Okay, QS is 1. The ratio of QS to QV. So QS would be 1, QV would be 3, the ratio. And this one's a little bit tricky. All right, so here we go, 1 and 3. Down here, the ratio of PT, so this right here is, and it's not drawn to scale, it's 3, and PR is 4. I'm going to treat these ratios like they're the actual numbers. We need to find the area of PRST. So let's just start with that one, PRST. PR Where did the R go? Okay, PST. No, PST. PST is right here. So the base of PST, I'm just going to put it right up here since I'm room challenged anyway. PST, the base would be 3. So it'd be 1/2. The base, which would be 3. And I made a mistake already. I knew I wouldn't make it. The ratio is 1 to 3. So this is going to be, what did I do wrong here? Yes, this ratio QS to QV to the whole thing is 1 to 3. So this has to be 2. All right, so the ratio of QS to QV. So QV would be 3. So that's how that is. So the base would be 3, the height would be 2. So that's the area of the top guy. Okay, the area of the bigger triangle PQR. PQR. Okay, the base, it's going to be 1/2. The base of the big triangle is 4. The height of the big triangle, which would be this one right here, would be 1 plus 2, which would be 3. Like that. So we can cross out these 1/2s. We can cross out these 3's. The 2 goes into the 4 2 times. And so the ratio of the value is going to be 1/2. And that's the answer. Sorry to mess you up on this one. QS right here is 1 to this whole thing is 1 to 3. And you can see it is. This is the 1. And then this whole thing would be 3. So that means this has to be 2. So I just worked right with these ratio numbers. You could do it like with the base of 12 if you wanted to, but you can just work with those ratios like I did. Okay, time is ticking. Let function h be defined by this. So we know that h of 2m, so if we put a 2m in to the function, which means we're going to replace the x value by 2m, we're going to get 14 plus 2m squared over 4. And that tells you that if you evaluate it with 2m, it's going to equal 9m. So now we just made ourselves a little equation. So we get 14 plus 4m squared over 4 equals 9m. The 4's cross out. This ends up being a quadratic equation. So that means the exponent is 2, so you have to set it equal to 0. So you get m squared minus 9m plus 14 equals 0. Quadratic, so you have to set equal to 0. We factor it m minus 7, m minus 2 equals 0. So you're going to get 2 possible answers for this, either m equals 7 or m equals 2. A little bit tricky, especially if you don't quite understand functions. So functions, you're just going to evaluate. If it says h of 2m, that means you put the 2m in where the x is. And then it tells you, if you do that, you're going to get an answer of 9m. So you might need to study that one just a little bit more. All right, last board. Some fun ones here. A merchant sells 3 types of clocks that chime as indicated by the check marks in the table. What is the total number of chimes of the inventory of clocks in the 90-minute period from 7:15 to 8:45? All right, I'm going to assume that you guys struggled through this one. I won't go into too much detail. But what I did, I just set up all the 15-minute intervals. So 7:15, 7:30, 7:45, 8, 8:15, 8:30, and 8:45. So chimes indicated, what is the total number of chimes of the inventory? I don't think we needed, I think we needed the 7:15s. No, I don't even think we needed the 15s. So you didn't even have to do that. You could have just done the 7:30, 8, and 8:30, I do believe. Okay, so let's do clock A. Clock A chimes, there's 10 clocks, and they each chime n times on the nth hour. So there's 10 of them. So on the 8th hour, it's going to chime 8 times. And there's 10 of them. So it's going to be 80 chimes. So that's the first one. So n times on the nth hour. The nth hour is 8. So it's going to chime 8 times. And they're going to chime once on the half hour. So there's 10 clocks. They're just going to chime once, all 10 of them. And here we go, 10, all of them on that time. Okay, B. I don't know why I put the 15 there. 7:15 and 8:15. Okay, type B, there's 5 clocks. They chime n times on the nth hour. So we only have 8 times 5. They're gonna chime 8 times at 8 o'clock, but there's only 5 of them. So it's gonna be 40, half as many. And they don't chime at all in the half hour, so we don't have anything there. All right, C, they chime once on the half hour, and once on the hour and once on the half hour. There are 3 of them. So this one had 10, this one had 5, and this one had 3. So every half hour and on the hour, they're going to chime 1 time. So it's going to be 3 chimes here, 3 chimes here, and 3 chimes here. So I just made myself a little chart, and then I just went and I added them all up. This added up to 123, and then I had 2 13s, so it'd be 26, because these would be 13 and 13, 26, and so the answer is 149. That takes a little bit of thinking. You're not going to be able to do it as quickly as I just did because I thought ahead of time. But that's one way that you can do this problem. In the little TED book, he says skip this one, but I didn't think it was that bad. All right, a little probability here. You have 5 cards are placed in a row so that you can come up with all the different combinations for this. Here we have 5 cards. I recommend when you have these, you do 5 lines like this. 5 cards are placed in a row that the shaded one is never at the end. How many different arrangements are possible? So the shaded ones are never at either end. If you had any probability teaching, this problem's not so bad. If you haven't, you're just going to have to label these 1, 2, 3, 4, 5 or something like that, and just try to figure out all the combinations. The problem is that I do believe there are quite a bit of combinations. Here's the way you do it if you know how to do probability. The first spot, how many of these cards can fit in the first spot? Well, we can have 4 of them. We cannot have this guy. So there's 4 possibilities for, what are they called? Cards. Now, if we go here, there's 5 choices of cards that we could put there. So, yeah, let's see, why do I only have, so, okay, so there's 4 cards. All right, we can't reuse a card. So there's 4 possibilities. This one can't be there. So we used one of the cards. So let's just say we used this card. All right, let's go to the next spot. How many cards are available for the next spot? Well, there's going to be, oh, we're going to fill in. Sorry, I should have looked at this one ahead of time. We're going to go down. You always fill in the ones where there's constrictions. So we used this card. So there's 4 cards left to be placed. We're going to go down here because we can't have this card on the end either. So how many available cards are there? There's 1, 2, 3. 3 available cards for that guy. All right, so we couldn't use this card, so we're going to scratch him out. All right, so we used 2 out of the 5 cards so far. How many cards are left? We have 1, 2, 3 cards. So we can put any of the 3 cards here. So let's get rid of him. How many cards left for this spot? There's only 2 cards left. And then there's only 1 card left for that spot. So you multiply these all together, and we're going to find out that there's 72 possible ways you can arrange it. So with these, just remember to start with the ones that have constrictions first, and then work your way to the other spots next. I'm just looking to see if Ted Turner tells us any other way to do it. He doesn't have a better solution, so That's the only way, unless you want to write out all 72 combinations or figure out some other pattern. All right, so sorry that was such a quick overview of section 6, but that is all for section 6. Test 4.